Good.
I got one yesterday. All right, folks, we're going to get started as it's just past the hour. So this is MIMI, More Instant Messaging Interoperability, the first of 2 sessions this week at IETF. We have quite a lot to discuss here, so we're just going to buzz through the chair slides to get to the meat today. So first, the note well, so please be aware of the intellectual property policies at IETF, as well as the mask policy, which given local regulations means you don't have to. Okay, onto the agenda. So today we're going to start with a discussion of some of the open requirements items. First off, we're going to have Richard talk us through the questions of what is a noting provider and do we need one in MIMI? Then we're going to discuss whether client-to-server interactions, not to be confused with either client-to-client or server-to-server, are in scope for MIMI. Then Rowan's going to enlighten us on design requirements for transport service. And then we have a couple of decks on the linearized matrix and then MIMI delivery service drafts. All right, so that's today. Then on Wednesday, we'll cover all this in more detail, and there'll be more links to more slides and drafts by then. We're going to cover some more requirements that aren't essential to the transport discussion, and we'll take a look at some drafts about user discovery. And last thing to cover before we get in is we just want to shout out these great stickers that somebody made. We don't know who. If you choose to remain anonymous, so much the better, but like, thank you. These are really cool.
Where are they? There are none left.
Yeah, I know. They're sneaker netted around. We don't know. Okay. So if you did make them, I don't know, come say hi to us, chairs, and then we'll thank you. Yeah, seriously. So before we move on, agenda bash, does anybody have anything to bring up? Sounds like no. So Richard? Oh, good point. We do still need a note taker for the session. Do we have any volunteers? And yes, please sign the blue sheet. Note. Thank you. All right. With that, let me bring up your slides.
So welcome everybody. My name is Richard Barnes. I'll be your designated neutral topic introducer discussion kicker-offer today. The chair has asked me to do this presentation after the questions were set, so you'll get a little bit of what was on the agenda and a little bit of my interpretation. And please let me know if I'm not quite shouting into the mic loud enough. I'll try harder. How about now? Great, cool. This thing doesn't appear to be moving it. So Tim, can you drive?
Yep.
Next slide, please. So hopefully the next 3 slides will be motherhood and apple pie. We will all agree on what is on these slides because they were just trying to capture what I understood to be truisms that we've all agreed on so far. So this is to establish a baseline for what we'll then talk about, what we'll then disagree about later, or hopefully agree. So next slide, please. Oh, by the way, we should probably write an architecture draft at some point. Happy to collaborate on that if other folks are interested. So this is to kind of describe the overall logical structure of a MIMI conversation. So the room, and some of these the terminology here will overlap with individual proposals. Some of them are matrixy terms, some of them are DSE terms, some of them are other things. Please understand them all as abstract things, trying to capture general intent, not what it means in a specific proposal. So the idea is that a room has things happening in it. It can have messages being sent. It can have changes to state, things like that. There's because MLS is involved, there's a need for some sequencing. So I've drawn these as a sequence of events here. So that's kind of the room is the logical grouping, the logical construct. It is realized by a series of participating servers that represent different providers that are participating in this conversation. Then ultimately, there are clients that represent users in these interactions. So far, so good. Everyone agreeing? Is this looking familiar to everybody? I'm seeing some nods. Okay, good. All right, next slide. Let's see if we can keep going on the agreement. So it's trying to capture overall what the protocol stack looks like. So the bottom layer here kind of aligns to the entities we had on the last slide. We have clients on the end, servers on the middle. I'm trying to capture here that the transport pretty much captures the server-to-server interaction. How do the servers who are interacting and creating a room create the room together, realize that logical interaction. And acknowledging that there are some provider domains off to the side where there may be unspecified interactions between servers and clients that are not the business of the IETF, not the business of the MIMI working group. Now, above that transport layer, getting things from end to end, we have these end-to-end security layers, right? You can have things that are end-to-end authentic, so they're signed by the endpoints, but not encrypted, so they're visible to the servers as they transit. And you have end-to-end confidential information that is signed and encrypted so that the servers can't read it. And on top of all that, we have message formats that actually create the application layer functionality and say, this is, a reply. This is, I'm telling Rowan I love him today. And all of that. So does this stack overall look familiar to folks? Look sane? Anyone serious reservations? Thumbs up from Matthew. Thank you. All right, good. Next slide. Let's continue to agree. So this is a little sketchier because we're still working this out. But the general idea is that a room, this interaction framework we have, has some policy attached to it that says what can happen in that room, what's allowed to happen. So that captures things like, who is entitled to do what. Those are the largest things. How is someone allowed to join this room? Things like that. So overall idea here, there is a policy attached to a room that expresses some things like this. Rowan has a good draft expressing some other stuff. There's some good stuff from Matrix. But in general, there is a policy attached to a room. Someone can set that policy and someone enforces that policy. Good? Nods. Cool. All right, that is my setup. Next slide, please. Let me skip through. So first question the chair has asked me to talk about was this notion of an owning server. And when I looked at that on the agenda, I was a little puzzled. Next slide, please. So there's multiple notions of ownership, it seems like, floating around here. So there's, at the transport layer, you could have a notion of ownership. So, this server is the physical hub for the conversation. Everything that happens in the conversation, every message that affects the state of the room passes through this server. And you could have that be a pure transport level construct, something that could do that, just as a pure fan out, not aware of any of the logical state. So this hub notion, I wanted to call it, as one possibility for what we mean by ownership. The kind of next level up is, if you're in that hub role and you're seeing all the events, you can apply filters to those events to enforce policy. So when you get a message, you could check and access controls and say, hey, is the user that sent this message allowed to send this message? If the user tries to kick someone out, are they allowed to kick someone out? So you could be a policy enforcer when you're in that, especially when you're in that hub role. And then the third notion of ownership is policy control. Do you actually own, can you dictate the policy that applies to this room? And there are various levels of control you can imagine. They're dictating the policy being the most restrictive version. You could also envision roles here where a policy controller could set a boundary for what the legal policies are, and then maybe clients or other participants in the room could specify the nuances of the policy. So I wanted to kind of call out this taxonomy of ownership as something where feedback from the room would be welcome on which of these are necessary to have as a unitary single thing in the room. I've called out at the bottom here some ways these are non-orthogonal. A lot of it comes down to this hub thing. You know, if you're going to do any policy enforcement, especially, it's useful to have this hub thing so you make sure the policy is always enforced. If you're going to have policy enforcement as well, it's important that whoever's enforcing the policy understand the policy. And so that puts a constraint on how you can do, adaptability and extensibility of policy languages. So there's a little bit of constraint on the policy controlled by virtue of having a policy enforcer. So next slide, please.
Yeah, Ecker's in the queue. Would you like to take that before we move on?
Yeah, go ahead, Ecker.
Yeah, so, so first of all, I think there's another notion of owning in this case, which is who's responsible for storing the state associated with the room. So in particular, any room, obviously, the delivery service has to know where to send the messages, which entities get the messages, to keep track of which peer services and which local. And so that's like the most simple, I think, notion of this concept, right? And none of this doesn't quite captured by any of these. It also seems like it would be kind of unsatisfactory to have said service not do any policy enforcement for the obvious reason that I don't really want, even if I can't, even if the messages are not part of the MLS group, allowing random people to send like all kinds of messages to like hither and yon is not attractive property.
Yeah.
So I guess I'm sort of I think debating this taxonomy a little bit, but B, sort of weighing in favor of some policy enforcement at minimum.
Yeah, I mean, the question we'll raise, I think, on the next slide is, what version of ownership does this protocol need? And so amendments to the taxonomy are welcome, because this is just intended to kind of lay out a few axes that were obvious to me, but others welcome. Yeah, Rowan?
Yeah, Rowan May. So I think an important aspect of this for like a policy enforcer would be to say, it seems pretty obvious that if you were going to send a commit and one provider or one server was responsible for saying, yes, this commit of the 3 that I received simultaneously is the one that is going to get fanned out. For me, I would put that in the policy enforcer category and not in the hub category. Whereas pure message fan out, I would put in the hub category.
Okay. Yeah, that's fair. But and maybe that's another axis to keep in mind here. To the degree that we are dependent on MLS, without inventing some new distributed flavor of MLS, we need someone to act as a sequencing arbiter to dictate the sequence of at least the MLS messages.
Of the commits.
Yes, of the commits. Yeah. Okay. Can you hit the next slide? Yeah, so this, given that we have policy, there is underlying this a question of policy control. I'm not sure I want to spend a whole bunch of time on this, other than the last slide, that there's this question of who sets the policy for a room. There are a few different answers you can imagine to that. You could have a system where only a single owning server unilaterally sets the policy for the room. You could have a system where other servers participating in the room can contribute to that policy. There's some collaborative process. I think there probably needs to be some way for clients to have input into the policy for the room, possibly via a server, just so you can have things like where I grant Rowan permission to be a moderator in this room, for example. I have admin permission, say, and I grant Rowan moderator permission. So there's this kind of unitary server, multiple servers, clients, all in the mix. And so like there's this question I think we need to address of what sort of policy control model do we have? Who is allowed to set policies? It's kind of another layer of nuance on this ownership question. And the last point here I'll point out is that like this client server provider thing is not totally distinct, because there is this kind of provider domain where there can be off book outside of the protocol coordination. If there's enough coordination between a server and its clients, the clients could basically reflect some provider policy into the room, even if you had a pure client-driven model. Yeah, PHP.
Maybe a simplifying. In databases, you have 0, 1, and many, and those are the 3 cases when we're looking at things like this, if you've got a room with 50 people in, that's one sort of thing, and you don't need to bifurcate the control, distributing management of that over 3 different servers makes very little sense. You just, distributing for the sake of making it more complicated. If, on the other hand, you've got 10,000 people in the room, yes, you've got 10,000 people in the room, but if you've got 10,000 people reading and writing in the same room, well, it's not going to work. And so I think that really large rooms turn out to be a completely different kettle of fish. And you probably don't need to consider them in the same way, because your access into the room has to be so limited, because you can't have 10,000 people talking at once. You have 10,000 people listening. And so actually, when you come down to it, I don't think that you have the requirement for multiple masters all trying to manage the same room at once.
I see where you're going with that, but I think an important clarification to the use case here is that the servers we're talking about are not sort of multiple replicas of the same logical data store. The servers are effectively different autonomous systems. And so they may have different opinions about what the state of the policy should be. And so even in a situation where you have only 3 users, 1 per provider in the picture I had before, that may still be worth having some sort of coordination protocol so that those different opinions about what the state should be can be somehow combined, or at least reconciled or acknowledged. Again, this is setting up the discussion for people to have opinions, but thank you. Yes, the next slide is
Before we move on, there's a Jonathan's in the queue.
Sorry, Jonathan, please.
I assume we want discussion on these as we go along. Yeah.
Yeah, why don't we do a kind of clarifying and elaborating discussion?
Clarifying now?
Yeah,
Well,
sure. And
Then
we'll
I'll
have-
sit down. Thank you.
Okay. Yeah, the next slide is the discussion tier upper slide. Yeah, so the question here is like, what do we need in terms of ownership? So like, which of these notions of ownership do we need in the protocol? Do we need a physical hub server, for example? Is that hub server also applying policy? And then what's the kind of policy control model that we envision here? Is it mainly client driven? Is it unilateral server driven? Or is there some collaboration? So I think that's the kind of last framing I've got. So please take to the floor and discuss among yourselves. Jonathan, I think you were first.
I was like trying to get myself back in queue. Jonathan Rosenberg, 5'9". I think a useful litmus test to help make many of these decisions is to recognize we're not in a greenfield environment. We're dealing with existing gatekeepers who have products that do what they do. And it is not, I think, within our remit to tell them how to design or change the products that they've been shipping. And I think that helps educate some of the answers. What I was going to say, for example, on the policy question is that each of these gatekeepers has a set of policies they do today. Like they don't support all these different room types and variations. And so that forms a envelope over which, hey, if I say WhatsApp, I'm owning this thing, I don't support this type of thing. So no user can elect those options. They can only elect ones that are supported by my product. So when it translates to a protocol, there is a boundary that's set by the provider, and they're not the same across these providers. And so practically, like, I don't know how to make this thing work at all.
Well, yeah.
Without someone owning it, they're the hub, and they're the one who dictate the envelope of the policy that defines what it is that users can do based on the product they already have or decide to ship in the future. So that's my view on that one.
Becker?
Actually, next. It's hard to tell.
Yes, you are.
So I think I largely agree with Jonathan. Sorry? I largely agree with Jonathan, I think. I don't see how this works without as a practical matter in the real deployments we have, without the owning, that being the existing services being able to influence the policies that are applied in the room. I don't think it practically works without them being able to actually enforce them directly, rather than having them enforced by somehow notifying the clients and having the clients enforce them. I don't think that's going to work very well. And if it did, we need to find some new language for doing that, which seems incoherent. I think it would be like remarkably simpler if we assume there's some designated provider in any given chat who is able to do these things, and then that's hard a problem to solve as it is. So I think that's where I'd want to go with this. I do think the clients should be allowed to influence policy. For instance, you could say there's a closed room and open room, so like the easiest version. I I think the interesting question that perhaps we have to grapple with is, what about people who are not the owning provider on our servers that have any authority whatsoever? So a concrete example is, is this this is a chat which is owned by provider A, and provider B joins, and then and then someone joins the chat from A who B thinks is a spammer, or B thinks is a criminal, or whatever, and could they have any opportunity to influence that at all? I suspect the answer, regrettably, we know, because I'm not sure how to design. I don't like that any more than you do, but I think designing, I worry about the situation we have glare.
Yeah.
You think that would be or would not be possible?
I think it's going to be very difficult to engineer something where B can influence.
And sorry, in this scenario, B is the non-owning
Yes.
provider.
Yes, I think that's regrettable, but I think it's probably the way we're going to end up. But I think that and I guess I would finally say that I think that what the clients can do and what the servers can do, well, they may have overlapping remits or different categories. Namely, the clients ought to be able to set overall policy within, as Jonathan said, the envelope, and then make specific targeted changes, like I've invited this person or kicked them out, but might not be able to do other things. For instance, they might not be able to filter messages from individual people, for instance.
Yeah, so I think that last point is probably a useful checkpoint for folks, where a concept we could establish here is that the servers establish a boundary of acceptable policies, and clients set specific policies within that. Is that thumbs up from Jonathan?
That's about what I expect.
Yeah,
Yes.
okay, good. Whoever's taking minutes, I think that's a good thing to record.
Rowan,
Rowan, I think you're up.
Rowan, you're in the queue.
Rowan May. So I described something similar to this in group chat, but where you have a provider says, okay, I'm willing to do rooms that do any of these things. Whoever sets up a room says, these are the things that this room does, and then can, potentially grant permissions to other users, including potentially users that are not on a different provider, if that's supported. And then in terms of the property that Ecker described, I actually don't think that's regrettable. I think what's necessary is not that the client can't influence whether, a user that it thinks is a spammer, that B thinks is a spammer, joins with A in a group hosted by A's provider, but that B knows what's going on and can decide whether to join or not. And so likewise, even if there was no spammer involved, if A set up a group and invited B, B could look at the room policy and say, I'm not okay with that room policy because there's a logger involved, or because there's a history, there's like 90-day of history backsend to anybody who joins. And I don't want to be on the record for that, for potentially unknown new joiners, for whatever reason. So I think that there is actually a very clear set of things that we can do that allow a policy enforcing provider that is an owner in that respect, a client who is involved in setting up a group, and clients from other providers have actually, I think we have an opportunity to enumerate a very nice set of rights for them to accept or not the conditions of the room, and possibly, if they're delegated, to be able to affect them. So I think that's a really nice property.
Daniel?
Daniel Kahn-Gilmore. So I'm struggling with this a little bit because of how abstract the policies we're talking about enforcing are. And I suspect that there will be policies that only the room provider can enforce. And there may also be policies that touch on things that the room provider doesn't have access to. Policies related to things that are under encrypted cover. And if we want one totalizing vision here, I don't know how we're going to square those things with each other. So I I feel like talking at this level of abstraction is challenging, and we maybe need to like just parcel out the types of policies that the room provider must have access to if they're expected to enforce it versus other types of policies that might be interior. And one other thing I want to keep in mind here is that as an end user, you need to be able to know who has access, who has control over the policies in the room and who's enforcing them. I want to make sure that the end user gets to see all of that from the infrastructural level up to the stack. I just think that's something to keep in mind.
Can I ask you a quick follow-up question? Isn't it the case that any policy that relies on access to something within the encrypted envelope is basically out of scope for what we're designing here, because it has to be between the client and it has to be like within the client or between the client and its own provider?
So, I mean, if that's the answer,
I'm not talking about protocol. I'm talking about something that actually, if you actually have to have access to something inside the encrypted envelope, that's what I'm saying. The policy has to act on something inside the encrypted envelope. How could it possibly be in scope for us?
So if that's the answer, then I mean, we're basically saying there has to be policy that is acted on not by the endpoint, right? I mean, that's what we're saying.
There's lots of policies that don't need this access.
Right.
So that's why I'm probing on this other category, which I hadn't really thought about before, which is policies that would need access to something inside the encryption envelope. That's like that's a new thing for me anyway. So that's why I'm asking.
I mean,
I mean, it seems like if you have a policy that's like, don't mention secret projects.
Yeah, exactly.
Right.
Right.
So that can only be enforced by someone who can see the content of the conversation. And clearly that can only be enforced by someone who can see the contents of the conversation. So I think it's just, I think you could imagine providers setting that sort of policy, but a provider can't enforce that policy at a server. And just talking about kind of physics here, not even like engineering desiderata.
right.
Does that seem correct? Yeah, so I think that means, I think the upshot of that is that there may not be any protocol considerations for us to specify about how that's enforced, but we could still potentially have some considerations about how it's specified and put in place.
So can I give an example of something that might be inside the encrypted envelope, right? So who gets to join the group in terms of who is given access to the right pieces of keying material to join into the keying material, right? If the room provider can influence that, can change that, then the room provider needs to have access to the key material to be able to delve to open the encrypted envelope, right? So I would.
No, you can have membership controls without having the ability to see content.
Well, but to add them to the membership, then some key material needs to be visible to the new member, right?
Yeah, there's public key material you can provide to the next participant.
Okay. So
now there's some history issues, but to the first order that you can deal with public key material.
Right. So okay, then history is an example of something that's inside the encrypted envelope, right? So that's a policy.
If a server was going to add someone to a room and give them the last 90 days of history, then the server would need to have secret key material.
Right. Right. And then the service ends up acting as though it was a member of the room. Right. So anyway, if we're thinking about those things, then we need to think about it as somebody who has access to the interior of the envelope.
Yes.
Right. So this conversation is helping me to think through what we're talking about. It sounds to me like we don't want to talk about the stuff that requires inside the encrypted envelope in this conversation. Okay.
I think, yeah, I think we would
I'm getting some grimaces from Warren, although that might just be the normal resting expression.
I mean, I think we would have a good, useful decision here if we came to a decision that only dealt with policies that servers could enforce. Yeah, Matthew. Or actually, I don't know.
Yeah.
In terms of the question of whether servers should enforce, from my perspective, it's a categoric yes. And there's a real danger here that if the hub is the only thing that enforces policy, then the hubs from different vendors, different gatekeepers, or whoever it is, could go completely off message, applying their own rule set. So from a user perspective, you need to be able to configure the room in a consistent way, or at least bridge the semantics that your existing provider has through to a common language, which everybody then can enforce. Also, if you're moving the hub around the place due to the hub going down, or you want consistent conversations hubbed by different providers, which obviously is desirable, again, you need to have a consistent rule set. However, I think it's important that all servers can also just reject whatever messages they want based on whatever rule set in addition, and that could end up with split brains. But just from a pure anti-spam perspective, if a given provider has decided to blocklist another provider for whatever reason, even though it would be a horrible experience for the people in that conversation, it's really the equivalent of an email situation where on a given distribution list, if some of the SMTP servers can't talk to one another, then it's going to be painful. It's unusual, it's unlikely, but people should reserve the right to do that.
Rafa Robert. So yeah, I think we also need the hub to enforce the policy to do the message sequencing as well. And to go back to the question of DKG, I think we probably when we initially thought about that, we thought about group management policies. So essentially what Rowan has been drafting up, like what types of groups do we have? Open groups, groups where you can only enter with an invitation, groups where, I don't know, where you have admins, where you have moderators, etc. So this kind of policy is something that can be in the clear and that can be enforced by a server. And what's important is that that is absolutely transparent. I think that's been said before as well. It should be transparent to the server. It should be transparent to other servers that connect in that instance, and it should be transparent to all of the clients as well. So, and it should be enforced first and foremost at the server level, but ultimately clients could also enforce things if the hub goes completely rogue and doesn't stick to its own policy.
Pete Resnick. So I need an example or two of services, of policies that the server can actually implement other than deliver or don't deliver this message that I don't have visibility into. Because I'm having joining, so open or closed, I don't even understand how a server implements that, because if I can, as a client, hand you as a client the public key to join the room, then the hub can't implement stopping this from being an open room effectively. What kinds of policies can a hub actually implement, or can a server actually implement?
Yeah, Rowan, why don't you go for this? Someone who's actually run one of these servers, please answer.
Hi, Rowan May, and yeah, I put myself in the line to kind of answer some of Daniel's questions and to try to make these more concrete. So a couple of examples. So if you have let's assume for the moment that our providers are the second level, the provider enforcing. And in that case, we had, in the sort of the very basic case, you want to have an membership only group where there's an administrator that can decide to add people, or you have other ways to join, like via invitation links. So those things are supported by lots and lots of different services out there. It's a very popular model. And in this case, the owning provider, it can hold there are several different joining styles, but in the joining style where somebody tries to just go and join, in order for them, for example, like one of my existing, a client of an existing user wants to go and join. If they want to do that, by virtue of the fact that the same user is already a member, that could be authorized, and they can request this thing called a group info in MLS, which allows them to go and join. And so that provider could gatekeeper this group info on the basis of the policy that was defined, and is sort of jointly enforced by the provider, but the clients also get to see it. And the clients can have this thing in MLS called agreement, where everybody knows what the policy is and it's burned into the group. And so if they see that that provider all of a sudden added someone in a way that's not in accordance to the policy and the authorization rules, they can cry foul. They can send a message to the group. They can pop a big klaxon warning signal to the end user. They can just automatically drop out. All kinds of things. They can prevent the user from typing something potentially incriminating. But the point is that there are roles for everybody, but in this case, the owning provider can have this role of having this kind of minimal enforcement. Another example would be, say, logging. So let's say that I have somebody who works for a financial services company that requires logging of all conversations. And so you can have a user that's clearly identified as this is a logging, this is a logging bot or whatever that's in some room. And then you have somebody from an auditor that goes and joins this group, and the auditor has their own logging policy and they need their own logging bot. And everybody can agree that there are two logging bots in this conversation, and anybody that doesn't agree with that policy knows and doesn't, can decide even before they go and join that, this is a policy I don't agree with, or maybe I need to go and prompt the user because I've never seen this situation before, and I need to say, hey, do you want to allow this permanently for this domain? Do you want to allow this one time, or do you want to skip joining? Right. So those are some examples of policy things that we can do with this, level 2 policy enforcement. But most importantly, just figuring out the order of who gets to commit an MLS message is also pretty fundamental, and I think that that's quite important. And I think for the number of providers that are interested in using MIMI, I think I think a lot of them are going to be interested in this sort of level 2 enforcement, at the very minimum of being able to decide which commit gets a bite at the apple at a time. Thanks.
So Jonathan's up next, but before that, we still have some stuff Richard needs to get through, as well as Rowan's deck. So in the interest of time management, we're going to close the queue in about a minute. So if you have something you'd like to say to these questions, please join the queue now.
So in the interest of giving people something concrete to throw things at, I wanted to go ahead and try and articulate a thing we would put an up or down, yes or no question to. So the straw man policy for you to set your matches to is, there is a single hub for distribution and sequencing for a given room. For policy control, there is a single owning provider that sets the policy, or the policy envelope, because we had the thing about servers and clients, the policy envelope. Everyone who's involved in the room has a consistent view of the policy, and every server enforces the policy for whatever passes through that server. So that's the straw man. So please continue discussion.
Jonathan Rosenberg, 5'9". I wonder if the way to think about policy is more document once, enforce twice, because in essence, MLS means that at the end of the day, the clients are making decisions about whether to accept a commit or something like that. So the model, I think, works, and this is what I thought your draft was trying to do. I may have misunderstood, Rowan, but was trying to basically define a document format for specifying these policies. And the idea is that they would be broadly understood by the server, that's the hub, and by the clients. The server enforces what it can, and it's almost like a double check that the clients also use this to decide what they're doing at the MLS layer of the system. And so that almost gives you a second layer of protection. So the example is let's say there's a policy that says anyone can join the room except for Rowan. The server can enforce that, but then the clients can enforce it too, because if they happen to see a commit that tries to add Rowan to the room, they would just not accept it. And that's, I think, that to me is the model that is starting to make sense. So document once, enforce twice.
So, Philham Baker. So I agree with most of what Richard said about the straw man, except while I agree that you want to have one server, one computer that is making, you're going to need to have multiple moderators able to make policy. And one of the reasons for that is that moderators drop out unexpectedly. And one of the things that you probably need to also think about is, what is the policy for creating a moderator or an administrator if all the moderators have dropped out? That's one. And another, because of the way you're doing this as gateways or whatever, what happens if I'm starting this on WhatsApp because that's where I happen to be, and then I drop out and there's no other WhatsApp person? And because of the way you set this up, you've got to think about that transition of the whole thing from one service to another. And we're still trying to do this as gateways, not writing a protocol. I think is an interesting choice.
Yeah, but I think that raises a useful additional nuance on the straw man I put up, in that all of that was intended to be at a given time. I think we still have this notion of that it might be possible to port from one owner to another over time.
So on Wednesday, I'll briefly speak about the portability draft. So essentially, what that means is that while we agree on having one hub, that doesn't mean that that's one hub forever. It could be shifted somewhere else.
Awesome, thank you.
That's on for you, Google. Richard, I kind of agree with your strawman proposal. I think it makes a lot of sense. I think one thing that's really important for us to think about is not everybody going to be able to enforce all the policies, because different messaging could have, messaging providers can have different ways of doing things, or something new can come up. So having to think about what is the fallback mechanism for a lot of these policies is going to be really important.
Yeah, and I think that's an advantage of having a transport level hub who is also, actually, let me add that nuance to the straw man, that the transport hub should be the same service, the same provider as the owning provider. Because if we have that alignment, that guarantees that everything goes through the hub, and the hub understands the policy for the room. And so you have at least one, and then the other enforcement is just backstop to that. True. Yeah. I think, just paraphrase, like if we have a portability mechanism, we'll need to deal with those sort of consistencies from the old hub to the new hub. Yeah, thanks.
So Warren Kamari, I think I largely agree with your straw man, except that I think you said that clients need to be able to evaluate the policy when joining. But the thing is, the policy might change over time. And so I think if the policy changes, the client needs to be able to reevaluate it each and every time there's an update to it.
Yeah, I think what I meant when I said everyone has a consistent view is that even if the policy changes over time, at a given time, everyone agrees on what the policy is. Yep. Yeah, if we do it that way. Yeah, Matthew.
Matthew Hodgson. Just wanted to +1 and say yes to Richard Strawman, which looks good, with the proviso from PHB also that having you need to define who else can edit the rules in the policy. I think that might be a bug in Rowan's proposal at the moment, and that only the administrator is allowed to set policy, whereas having some kind of hierarchy under that so you can delegate and moderators can drop out, etc., is really important.
Good. Okay. It sounds like the straw man is not entirely consumed by flames. So I don't know, chairs, how do you want to close this out?
I think we should do the rest of this deck, right?
Okay. Yeah, sure. Let's move on. Let's move on to the easier question. Thanks for keeping up with me through that abstract thing. This is a lot more concrete. So next slide, please. So there's we made this picture at the top that everyone nodded about servers being involved in a room, and events happening in the room, updating the room, sending messages in the room. But now when you get down to brass tacks, they've got to distribute this stuff somehow. We have to have actual messages flowing between actual computers. So there's a couple of different ways you can envision arranging this. There's what I've called the client to server to server to server to client model. It's even worse than SIP, where everything is provider mediated, right? So in this case, since we now have a hub, I didn't know we were going to land on that when I made this slide. Luckily, we have a hub. And so if some non-hub client originates an event, it goes up to the hub and then down to everyone else via their servers. So this is one possible protocol flow. I think it's probably what a lot of folks have in mind here. And I think if you look at the charter, this kind of server-to-server API is pretty clearly in scope. Next slide, please. An alternative architecture that some folks have mooted is where the submission of events, yes, the distribution of events still emanates from the hub out via servers, but sometimes events can get submitted by clients. So clients connect directly to the hub across domains. This is a reaching out beyond your provider domain to submit an event. This is the client to server to client model. So you lose one S. And the question is whether we need both of these. Next slide, please.
Let's take the queue first.
Oh, sure.
Are you wanting answers?
Well, that's the next slide, is like whether we do this.
Maybe we could just do a poll to see if
Yeah. Yeah, the next slide is just team questions.
Go to the next slide.
Next slide. Yeah, I mean, this is just an elaborate way of saying, do we need both of these?
Jonathan Rosenberg, I am strongly opposed to the bypassing the, I hate your acronyms, so we want to talk about that part. The bypassing the server, I think it's just not practically realistic. And also I think it falls in the face of authentication and authorization rules that inevitably require a relationship between the client and their provider, and there is none in those pictures. So I don't think we should go there.
Yeah,
Thank you.
let me try and short circuit the discussion a little. I think for most, in the conversations I've had with people at least, the default model seems to be the first everything is server mediated model. And so let's focus maybe the discussion on whether anyone thinks the second model is useful or necessary or tractable, or something we should do. So yeah, I heard a no from Jonathan on that one. So
do you want to speak in favor of the other?
Yeah, so I think I was one of the people who proposed that extra model. So I think the baseline has to be that if the clients connect directly to the hub, that they can satisfy all the requirements in terms of authentication and transport protocol they speak, etc. So that at the end of the day, for the hub, it looks as if another server was connecting. Because otherwise, I fully agree, this could be hell in terms of authentication, etc. So what I'm in favor of is to keep that as an open question if we can, or as we look into the transport protocols and the delivery service, etc. That we don't close the door completely on that, as long as we have this baseline.
So Raphael, just to clarify, the model you have in mind is effectively that if there was going to be a way for a client to directly connect to the hub, it would basically be as a single client provider. The client would act like it was a server.
Yes, it would speak the same protocol or almost the same protocol. It could authenticate in a way that is acceptable to the hub, so that the hub does not incur any additional risk by allowing clients to connect to it directly. If we cannot achieve that, then of course, the question doesn't make sense, but there might be a way that we can actually achieve that. And that's why I'm proposing that we keep the door open for that.
Rowan May, could you please go to the previous slide? So I don't have any particular desire or reason for the client to talk directly to the server, but I will observe that we could model this as that client is just a guest client on the hub server. In other words, that is a provider. It can do whatever it wants with its clients. And so if it wants to accept clients from another provider using some simple or complicated mechanism, that's its choice. And so for what we do here, we just say we have a server-to-server protocol, and here's how that works. And if we later want to specify how to do that, we can in the future. But we're not explicitly going to say, like, right now we are going to go define this protocol from here to there. So that's my suggestion.
Let me just read that back to you. So you're saying that inside these provider boxes, right? That's not scope for MIMI. We don't know what happens in there. And so there could be like a port on that side of the hub that a client from some other domain could talk to, and that wouldn't be our business. And they could do it. We could define something later, but a provider could do it off book to start with.
The scope of what we're doing, in the immediate future, is we're going to go and do server to server, and this leaves the door open that somebody who wants to go do that can do that, and could even potentially define that here in MIMI after we finish our milestones.
Jesus. I mean, I would definitely close the door on this. I might not like deadbolt it, but I would like close the door on it. Like, we have so much to do here, and we're like not even like, this gray circle is like hard enough. So like, I really would like not to make it any harder. And as Rowan says, like, people can make their own external arrangements. And I think as Martin's about to say, maybe this is some other protocol. This is on the side that you talk to your provider with. But like I don't want to even think about this for a very long time. And I certainly don't want to like spend any effort like trying to make it work and then rejecting it. I just want to reject it and then come back to it maybe later someday.
Yeah, Martin Thompson, to Rowan's point, which is not what I got up here to say, was that at that point you've got a different client potentially. It's not the client on the left, it's the client on the right. And that's potentially problematic in this case, because working out that this is the same person is not something that I know how to do without like, pfft. So like Ecker, I think we'll probably just pass on that one. There is a third model that Richard hasn't explored, and I don't like it, but I want to make sure that it is discussed so that we can put a nail in it, at least for now, because I think it's potentially an interesting one from a performance perspective, and that is the one where the client talks to their own provider, the server for their provider, and because the state of the group is known to that provider, some messages can go directly to the servers of all of the providers. So potentially some fouling out happens on the ingress. This changes the hub and spoke model, but potentially avoids an extra hop. I want to make sure that that is discussed and then put to bed, because I think there's a lot of complications there.
Matthew Hodgson Matrix, where we have architecture on Matrix today, and we're consciously not proposing it for MIMI, because whilst it has very desirable properties in a very decentralized environment where you've got network partitions and you want to have complete sovereignty and autonomy for all the different servers, implementation-wise, it's a lot more complicated than the hub and spoke model that we have here. So I'm glad it wasn't me bringing it up at this point. I've stopped banging that drum. Instead, we're pushing linearized matrix, which is when you go and simplify it down to a single server rather than having a mesh. Personally, I think it's a great design, like Git and many other things, but it's possibly too complicated for the use case here.
Well, hang on, Raphael, do you still want to speak?
Yeah, just one last word, because apparently I'm the only one defending it today. There were more people last time, I promise. So we have a chronology problem in the sense that there's a very easy way to do this sort of authentication with the delivery service draft that I will present later. So right now it's super abstract to see how this could possibly ever work in a safe way, etc. And that's why I understand that people want to close the door on it. Yeah, I don't know.
We can always simplify later.
Sure. I mean, then maybe we close the door for now, and at some point we can try and open it again if there is some consensus, and once folks are confident that it can be done safely.
Okay, so speaking of consensus, the two things that we want to come to consensus on here, requirements-wise, were owning provider, sort of materialized as the straw man that Richard presented to us earlier. The feeling I got from that, the conversation in the queue there, was that everyone's on board with the straw man. All right, I'm seeing nodding and no angry fist shaking, so I think we can record that decision. That's very encouraging. Sorry, go ahead, Martin.
Please write it down very clearly, put it in an email, send it to the mailing list, and have people like poke at it for a little bit before.
Since
saying
I made the straw man, I will commit to sending a draft of it to the mailing list after this meeting. I'll try and be speedy about it, Ron.
All right, and second decision is client server, yes or no, and it sounds like at least not for now. Going, gone. Thanks very much, Richard.
So we're like a little behind on time, but that was worthwhile. So we're going to just keep trucking through and see how far we get.
Okay. Hi, I'm Rowan. So I wrote two drafts. One was called Transport Design Requirements, and the other was called MIMI Group Chat. And I'm going to talk mostly about requirements in the first one. Next slide, please. So when I say transport design requirements, these are requirements on what? So we could potentially have requirements on the whole system. We could potentially have requirements on provider servers. We could have requirements on the abstract MLS message delivery service, on the MIMI message transport protocol, which is, I think we decided is server to server, and on MIMI client messaging applications or clients. So this transport design requirements is about implications on the transport protocol and with some implications on the MLS DS. Group chat is about kind of overall group chat functionality and talks more from a like user visible high level policy perspective, but to the extent that this is used as input to this working group, most of this will be discussed tomorrow, but these are requirements kind of on the whole system, but a major focus there is on client authorization. Next slide, please. So in the transport design requirements, I kind of go through some of the primitives that need to get sent around from a server to another server. The ones in bold on the top part here, the top half, are we need to be able to do certain operations that in the context of MLS, we really want to have a sort of locking or locking-like kind of an action. We want some kind of exclusivity. So being able to submit a commit, this means that if I have multiple commits that arrive near simultaneously, I want to pick one, and one of those will be applied, and the others will get a no thank you very much, please try again in the new epic. Likewise, if somebody goes to claim an ordinary key package that is designed to be used once and once only, we do not want to give 3 people the same key package by accident. And finally, group info. Theoretically, you could give group info to multiple people, but the purpose of getting a group info is generally to do an external join. And when you do that, you send a commit. And as we mentioned before, we really only want one commit to succeed. And so therefore, giving multiple people the same group info is sort of futile. So let's not do that. We also have, if we're assuming this straw man proposal that Richard mentioned, we have an idea of messages that are sent through, say, my provider, and they're going to the owning provider. Until they arrive at the owning provider, I don't really know whether they have been accepted. Like if it's just an ordinary message, it's very likely that they're going to be accepted, but it's also possible that while my message was en route between my provider and the owning provider, that someone just deleted me from the group, and so when it arrives, it says yeah, you're no longer a member of this group. You are not allowed to send that message because you're not there anymore. The epic has changed, and sorry, have a nice day. Finally, once those messages are sort of accepted by the owning provider, then they need to get fanned out. So if you read Raphael's DS draft, these should look quite familiar. And we kind of, independently came to very similar concepts of this. There was not really particularly collusion or maybe a little collaboration, but it's just because this is kind of how you have to do it if you want MLS to work right. Then I had other categories of things that you need to do between servers. So on the left side there, I have categories of messages which I call direct async messages. So these are things where, if I want to be able to give some kind of explicit consent, I might request consent to be able to talk to Travis. And it could be that Travis is online and sees my message and says, yeah, sure. And 30 seconds later, he grants me consent to go and send him a message or to set up a one-on-one group conversation. Or it could be that, he ignores me for a year. Or it could be that he sees this message and then blanket bans me for life. And then maybe, decides he wants to talk to me later. Right. So those kind of consent messages, reporting of spam and abuse, and even things like Knox and moderation, those are all things where it's a very asynchronous kind of operation. Jumping over here, then we have things which are status, where we don't really care about, I could have sent status changes, I'm available, not available, available, not available, 17 times. And the only thing that people care about is the most recent copy of that. That has different transport properties. And then there's sort of 3 extra little things that I included in this draft that are some unique properties of search and discovery, some properties of attachments, and some properties of invitation links. Next slide, please.
Let's hear from Jonathan first.
Yeah.
Jonathan Rosenberg from 5.9. Clarifying question. Are you calling these direct async because they require a user on the other side to take action and they might not be online right now? Is that what's in common between all of those?
No, not necessarily.
Oh.
I was more thinking that these, where having doing a REST style call of, I'm giving a consent request. I'm not going to get back an answer, in necessarily a timely fashion that says whether that was included or not.
But isn't the only reason for that is that you're waiting for a human? Well, why wouldn't you otherwise get a timely response?
It could be a human. It might not be a human, but if it was, but the important thing is that you cannot be guaranteed a timely response. And so therefore your software needs to act assuming that it is, 0 to infinity is the amount of time it might take for you to get some knowledge about this. So that's the only.
Okay, I just think it's easy to understand, but I understand your point. Okay.
Yeah, and I mean, this is like a 0-0, taxonomy here, right? Didn't expect to get it perfect. Next. Okay, so I just wanted to call out a handful of the implications that were discussed in this document. So one of them is that provisional and fan out messages between 2 gatekeepers could amount to millions of messages in a minute. And we really don't, even with something like, even with HTTP 3, we're not going to be sending individual, here's a message, here's a message, here's a message, here's a oh yeah, I got it back at 202, accept it, I kind of, there is a tendency to think in sort of HTTP semantics. And I just want to say, let's try not to think about that. Maybe you use I sent some stuff and I got back an accepted message for a big blob of things, but for individual messages or events, I think we should try to avoid thinking in that transactional way and think about sending blobs with a bunch of messages, and then asynchronously we get back information about what happened with requests that you sent provisionally or were fanned out.
These are the same thing. These are the same thing. Like HTTP3 allows for multi-streams. Like there's no meaningful difference between like I sent you this and I get an independent response, or I sent you 57 things and then you send me like these 5 succeeded and failed.
57 things or 5,700 things?
No meaningful difference. I mean, Martin, disagree with me. Go ahead. Okay. Like the whole, it's like abuse of the HTTP transaction semantics.
Okay, I think it might be worth hearing from people who are, if there's anybody who is operating a big enough network to comment on that, I would certainly be curious to hear their impression. But
I think Jonathan first.
Yeah, I mean, if you're going to send a million requests, send a million requests. And if you need a response to every single one of them, then you'll get a response to every single one of them. The batching thing, particularly for things that potentially have independent action, is problematic. And if you need to send a million messages per minute and your servers aren't big enough or something like that, just put more servers on. That's usually the strategy that we use when it comes to scaling. I mean, that's relatively small, so we should be all right.
I agree with that too. At the end of the day, the semantics of the protocol require a response to each individual action. And we now have transport protocols, thank you, MNOT or MDT group, that work pretty effectively at large scale without the traditional overhead of connect TCP and TLS connection setup. So all we're doing is inventing another layer on top of a protocol that already solves the problem. So I'm not in favor of the first bullet. Thank you.
Okay. All right. Second bullet is about ordering requirements. So there is I'm making a few assumptions about the way in which, in a common way in which delivery services are would be built. I'll discuss those in the next slide. I mentioned for sending commits that when we send a commit, often there is somebody who's added, and so if there's a corresponding welcome, I think it is extremely beneficial and efficient to staple the welcome to the commit, and likewise to staple the group info or something resembling the group info to the commit, so that a new joiner that wants to use server-assisted external joining, it can get access to that in a single operation instead of having multiple round trips. And feel free to read all about it in the document, and there's lots of discussion about that on the MLS mailing list and some stuff about that also in the DS draft. Another efficiency thing that I call out is key packages. If I'm going to fetch key packages for I want to add several people at once, and some of them are on provider B and some are on provider C. I think that would be quite logical for me to be able to ask for, okay, here is a list of users on provider B. Please give me key packages for one each of the clients with these properties for those users, and tell me if some of them are, if I can't have some of them as a single operation rather than having to ask for each key package one at a time. You may have a similar response to number one.
Hash include previous conversation.
Yeah.
Avoid trying to bundle things together where there is no, what you're looking to do is cut down on overheads or something like that. Usually what we find is that it's just so much easier to be able to say, I want key package for this person. I want key package, like individual transactions where those have individual outcomes. Bundling of those sorts of things is fine for something like stapling related information together for the same transaction, but when you're talking about essentially separate transactions, separate requests.
Please stay for a follow-up question.
Yeah.
So if I have to ask for key packages for all of your clients, just for a single user, I don't necessarily know which clients you have.
Right. So I think that's different in that case, because that's a single transaction. It's a request for all of the key packages for all of the clients of this person. So I think that's fairly straightforward. When you think about the case where you're asking your provider to provide to go off and find key packages for people on different providers.
No, not on different providers.
Oh, you're just
Multiple
looking-
users on the same provider.
Yeah, so now you're talking about a search effectively as the outcome. That's potentially something you could do.
I think the distinction here is, am I providing a list or am I providing a pattern? If I'm providing a pattern,
a list.
Yeah, then there should be separate transactions. Like, I mean, like I just want to say the model, like it's just this. It seems like the underlying model of HTTP that is in play here is wrong, which is like, I know it used to be expensive to run HTTP transactions, but now it is cheaper to run HTTP transactions. It was expensive as fulfilling them. And so if you try to break, like taking all this stuff and gluing it together like that just means that it's atomic from the perspective of the server, which means it can't fan it out. So it's actually, I mean, like I'll defer to somebody who's a CDN expert, which I am not. But my understanding is you'd be happier if you could fan it out. And so having them all glued together actually makes the problem worse, not better.
And correlating the client request to the multiple server requests.
I'm not sure I understood that one well enough.
Yeah, so in the scenario where you have to do multiple things as a server to serve a response, you're in a situation where you receive a request that says, do the following 10 things. You then have to do all of those 10 things before you can answer at all. Whereas if you have 10 separate requests to do this, do this, do this, you just go off and do all of those things and the responses come back whenever they come back. And there's no latency. You don't have this header line blocking problem that we spend a lot of time trying to fix in Quick.
And if you're the provider that is interfacing with the client and you need to likewise wait for all of those things to come back before you can.
Yeah, please avoid doing those sorts of things. Try to break them down so that every single transaction is discrete. And I think to Egger's point before, if you're talking about a search where you're saying, please give me all the things that meet these criteria, that's different, because you don't really know what things you're going to get back. But if it's a list, then those are separate transactions and are better served as that.
Okay. I'm going to pick one.
We're going to hear from Thomas, and then the queue is closed, so we can move on.
Yep. And this will be my last slide.
I just have one question around performance versus architecture. I understand why they're coming at it from their angle, but I think it ignores the performance and latency issues that might exist in real-time systems where you're not able to either manage the bandwidth any other way but through batching it or through managing the transactions one. And if you preclude batching, you can't manage it nearly as well as you could if you included it. So, sure. Here's an example. I'm a sub. I'm underneath the Navy. I've got a lot of stuff that got put to the satellite and back over to New York. And so in that case, the performance characteristics are much better if I batch it. Otherwise, another one, if I'm a very chaotic network, a lot of things going in and out, by me having transactions that some people are depending upon, but not others, yet having one complete thing would make it a better example to have one request, one transaction, right? So I'm just worrying, I guess my question is the issue here, and it seems like you're uncomfortable with it, is the issue here that you can't provide the performance management you'd like if you can't send them in bulk?
Yeah, so it's about the overall system performance.
Right.
Which, yeah, we will have vigorous discussions about in the bar and later. But
thank you.
I mean, I guess maybe we should start this later, but like I don't understand the batching point. The way this works in H3 is you blot all the requests over the wire.
You've said that
as
already.
fast as your like window and congestion window will sustain. And
Thank you.
whether those are one thing or, or a zillion things
Yes,
makes no
you,
difference.
you've said that. Yeah. The last thing I wanted to bring up was joining via link. So I think this is a common model for people to join. I think we need to have at least a way that somebody who gets one of these things from a different provider, that they can join successfully. If you go to the next slide, I'm just going to not going to talk to it. I'm just going to say these fan out and ordering requirements are listed in the document. If you have any concerns about ordering or head of line blocking or any of those things, please read these carefully. And that concludes today's thing. And I invite the next person. Thank you very much.
All right, thanks, Rowan. Okay, now it's a linearized matrix, right?
Hi, everyone. As the agenda said, this is, I think, Travis Ralston and/or Matthew Hodgson, and we're going to do and, albeit not at the same time, which means it will be an or. I'm Matthew.
I'm Travis.
And we wanted to talk about the draft that Travis has mainly put together around linearized matrix as a transport and overall framework for MIMI. But I have to say next slide. I'm going to say next slide. So before we jump into what's changed since IETF117, a quick reminder of what linearized matrix is. So this is a subset dialect of matrix, which, as I mentioned on the microphone earlier, is effectively a hub and spoke model for matrix, which looks to fulfill the requirements that we were just discussing on the transport side of things. What we did for IETF117 is to go and make it completely self-contained, because previously we'd basically linked out to the matrix spec to say, hey, this is what the subset would look like. Instead, it all got put into one great big 80-page internet draft. The reason for using a single monolithic one was, I guess, the implied idea at the time to expand it out to be self-contained. It could equally well, though, be split into various different components. But critically, there is zero dependency on the external matrix spec. Loads of useful feedback from Jonathan and many others on the draft, so thank you very much, everybody. And most interestingly, we've been busy writing code. So we've now got 4 different interoperable, actually 3 different interoperable implementations of linearized matrix. First of all, we've got Eigenserver, written by Travis with his matrix hoodie on, which is a really simple TypeScript implementation, a real toy implementation. It's about 1,000 lines of code from memory, which is it's completely self-contained for that. Then, in the last couple of weeks, we've also taken Synapse, which is an existing matrix server, and made it dual stack. So it can also talk linearized matrix as well as normal matrix, which has mainly been done by Patrick Cloak, who works at Element. Now, finally, we've also got, in fact, are these the right version of the slides?
Yeah, can you go back to the slide?
I think this is an earlier version. Yeah, this is going to be an anticlimactic version of the deck, because all of the big reveals hadn't happened. Because basically we did a hackathon as part of IETF at the weekend to go and do more interoperability, and the identity of the big tech gatekeeper gets revealed in that. Meanwhile, Richard has come to the microphone.
Yes, so Matthew, it's very plausible that you can take a very general protocol and specialize it down to something specific. So like these Synapse and Dandroid ones don't see, less convincing than one might.
Oh, I totally agree.
So has there been much implementation work kind of in the other direction, kind of starting from nothing and building up to LM?
Well, at the risk of spoiling the surprise, because we're trying to find the right deck, the work that we did on the hackathon was with the Google Android Messages team, who did an independent implementation whilst evaluating linearized matrix. This is no commitment from Google to use it or anything. It's just playing around for interoperability. And that was with zero input from us, without using any existing matrix code base, implemented purely based on the contents of the linearized matrix draft. And we sort of looked on to see how that was working. And by the end of the hackathon, it was working. And we've got some screenshots from that in the right version of the deck, if we can find it. But agreed,
not
we're
sure why
cheating
people
with the
should
dual stack version of Synapse because we already have all the objects flying around. And so we're coming from the sort of prior art of the existing protocol. But that's why it was important that Eigenserver is a completely, effectively clean room, albeit cheating by getting Travis to write it, who's an expert. But then the Google one is even more interesting in terms of being a third-party implementation. I'm going to start filibustering like Parks and Recreation at this point, unless we have some slides.
Sorry, it's
Or
not my
use-
fault. It's Firefox's screen sharing buttons.
Okay. I can do interpretive dance, or we could even just continue talking through the deck. Why, Travis? What is the overall architecture? Imagine, if you will, in your mind's eye, a block diagram. And what we've tried to do here is to really concentrate on the interoperability piece of MIMI. Like, MIMI is literally more instant messaging interoperability. So frankly, we're trying to go for the most boring tech, pragmatic approach possible. And at the bottom, you have, at least for now, a plain old HTTP RESTful API. Then you have an encryption layer on top, which is obviously, would be using MLS, but it's worth noting that a unique thing on linearized matrix is that it isn't a hard dependency on MLS. So for the Google interop, we've done double ratchet because that's what Android Messages says today, or you could remove encryption entirely if you so desired. And then on top of that, you've got payloads for the actual messages where we're using matrix event format, which exists today. And here we are back in the room. Yes, this is much more the slides I was expecting to be presenting. So we ended up only with 3 implementations in the hackathon: Eigenserver, standalone TypeScript, Synapse, which, as Richard points out, is cheating, and then Android Messages, which is not cheating, as an experimental showing an existing stack. We've also had interest on the mailing list from Cloudflare, who got on the Wildebeest team, were going and playing around with doing a Cloudflare workers-based linearized matrix implementation. Also an outfit called IronMail reached out, based in Canada, I think, who are also looking at this. Next slide, please. So here's a quick horrible screenshot showing the Synapse to Eigenserver implementation. You've got Element Web on the top left, talking normal matrix to Synapse on the bottom left, talking linearized matrix through to Eigenserver on the bottom right, and then on the top right, not that you can see it at all, there is the very, very, very crappy command line client to exercise a sort of fake client-server API, because client-server is not in scope here, in order to talk all the way through. The next slide's probably more exciting.
Richard's in the queue. Do you want to take that before you move on?
Ghost Richard. Okay. So here's another one, this time showing Element talking to Synapse, which then talks linearized matrix over to Android Messages. And you can see Android Messages there on the right-hand side, at least getting messages from Matrix to the Android side. I think we might have got it working the other way now today. When I say we, I mean the team at Google. Getting messages flowing the other way. But again, it's a real-life version of this, and this is a couple of weeks of work, given that the draft was only published, what, 3 weeks ago? Or early July on the Google side, and Eigenserver was, what, a couple of days to implement. So that's the kind of level of boring tech, keep it simple, stupid, that we've gone for. Next slide, please. This is the block diagram I asked you to envisage earlier, so hopefully it perfectly matches what you were conjuring up in your mind's eye, where you have linearized matrix at the bottom server side, and then you've got MLS, but you could have other encryption layers on top, and then you've got message contents on top of that. As I said, the Eigenserver implementation is dead simple, it's pragmatic, it's also proven messaging transport, given that it leverages all of the existing prior art for matrix, and then you just put MLS on top. Linearized matrix uses group management, it says, which is provided, linearized matrix is providing the group management, and we'll talk about that in a minute. Next slide. This should be pretty familiar in that we are talking about the amazing acronym with the CSSSSC architecture, begone set trapeziums. This is bouncing off client to server to server to server to client. With a hub and spoke, very much matching Richard's strawman from earlier, which has still not gone up in flames. Next slide, please. And I'm going to hand over to Travis for the science bit.
All right, so room versions are what we pretty much use to define the different policies or access controls in the room. They need a better name, as is mentioned at the bottom of the slide there. But the overall idea is that if you want to change anything to do with the access controls, you do what is equivalent to re-init in MLS. So you just abandon or delete or whatever the existing room or group, and you just create a whole new one. That allows for consistency on all of the different providers and all the different servers in the room, so they all know exactly what the ACLs are. They can't change, although they can be configured in many cases. But that's kind of the rough idea there. Questions before we move on for what that does?
Basically, algorithmic agility.
Yeah, I'm not seeing anybody just jumping up. So next slide, please.
We are in the next slide.
Maybe.
I'm trying.
Everybody hold hands and pray.
I will take the blame for submitting the slides 15 minutes before the session. There we go. Yeah, so events are currently what is used in Matrix. So they are effectively JSON objects and are just thrown around the transport, but they can change shape. Like they don't need to be JSON objects. There's a lot of base64 encoded binary in there, which would be obviously represented better with, say, binary. But overall, state events track the metadata in the room. So that is which users are in there, not necessarily clients, depending on your layering there, the room name, who is allowed to join, whether you can join without an invite, with an invite, or by asking for an invite through a knock. Power levels provide the access control overall, and that is the sort of meat of how that works. There's a slide much later on where we can go into more detail on power levels. But yeah, with the current model, MLS commits are sent as just room events, or effectively non-state events. They are just things that are emitted. They don't need to appear in order. They just kind of show up there. Jonathan, did you have a question clarifying this?
Well, I mean,
I have a comment on the MLS integration. I don't know if you have another slide or we should hold discussion to the end.
I would suggest holding until
Okay.
the end because we have a
All right.
second half of the deck, which might be applicable. But if I can get the next slide, please.
Sorry,
Yep.
internet is not working, so I can't really log in. You said they don't need to be emitted in a particular order, but of course MLS events do need to be in order. So how does that get executed?
So it's the idea that the event itself, since it's a container for the transport, it is not necessarily a container for the room. So the MLS commit can, commits do have to be ordered. It's the application messages which don't have to be ordered. That was the confusing part. Sorry. So yeah, the commits are ordered in linearized matrix. It's just a doubly linked list. So you can go up and down in a very, linear way. But yeah, the actual sort of user or application messages, those don't need to be ordered. They can just kind of go around in any particular order. Does that?
Let me try to restate what I think you just said, which is that the room events themselves do not have any ordering, but inside the room event, there's a commit message of some kind, and that has an ordering? No, okay, it's wrong. Good. So I'm glad I asked.
Events are ordered within a room in a double linked list, and some events could be MLS commits. So you're literally layering MLS inside the event payloads within that room, but it is ordered, and therefore you get your commit ordering from there.
Okay, so what is the thing that is not ordered then?
It's a delivery transport side. So the messages containing MLS commits would have to be in obviously strict order, but the events containing non-commits, I guess, or I guess even non-proposals would, they can arrive in any particular order, but the linearized matrix draft at the moment does keep them in strict order.
Okay, I think I'm still not quite getting it, but I'll pick it up.
Yeah.
It sounds like the two of you contradicted each other. So, I mean, I heard Matthew say all the events are ordered, and I heard Travis say only the MLS events are ordered. So, which one is it?
So in the current draft, it does keep a strict ordering, but it's mostly speaking to Rohan's specific delivery requirements and the actual ordering over the transport, where things can get a little bit fuzzy depending on what you are actually sending.
Basically, the events in the room are ordered for sure. If you want to, there isn't necessarily a strict ordering with the non-commit MLS messages on top of that. I think this is a very awkward way of us trying to agree with Rowan's requirements draft, saying yes, we're actually compliant with that, even though linearized matrix has an ordering at the room level. The next conceptual layer up doesn't need to be ordered for non-MLS commits. Correct?
Yeah.
High five.
Okay.
All right, next slide, please. We'll just get as far away from this as possible. So yeah, events currently in linearized matrix have a whole bunch of guarantees on them, so which are duplicated by MLS. More on that later, potentially. So the content hashes protect the actual modification of the event in transit, since it's carrying either encrypted or unencrypted contents, depending on what it is. The content hash will prevent the intermediary servers, wherever they are, from actually modifying that event. The reference hashes cover the event itself, including the content hash, and is also the event ID. This is primarily to ensure that if, say, over a transport, you are requesting from another server or from the hub, I need this event ID, it doesn't just give you something that is legal for the room, but arbitrarily different. The reference hash, in this case, because you just calculate it based off of the payload, it's not actually in the JSON object, means that you can verify that you've received the actual event ID that you asked for. Ecker?
Yes, so I understood that last point. And this is something I had trouble with the draft as well. But the first point, I don't understand when you say protect the event from modifications that transmits between servers. Is this merely for damage rather than malicious malice?
Yeah, so if the content hash were to change or be unverifiable on the receiving end, you just redact the event, which is basically to say remove anything that's not important from that event before sending it off to users, which traditionally in Matrix means you end up with a blank message. But with MLS, you have to keep a lot of the stuff. So the content hash here is of questionable value, in all honesty.
It exists for scenarios where you might not be using MLS, basically. It's the abstraction that allows different encryption layers on top.
But I guess I'm still confused because obviously anybody can change the message and replace their own replace the hash as well. So I don't understand what this is doing.
The reference hash and the signatures cover the content hash. So if you change the content hash, you're effectively changing the event ID. So therefore you are sending an entirely different event if you modify the event.
I guess the thing missing from the slide is to spell out that the IDs are the hashes of the event.
So I do get that part, but I guess what I'm trying to get at, so I guess this part I'm so confused by is like, I understand what a signature does, but a hash is like a detail of how signatures are created. And I like, in fact, there are algorithms, signature algorithms don't really have a hash, and like not in any internal way, external way. So, and I understand what content storage is in the case of the reference hashes, but I don't understand what the content hashes are doing other than serving as an input to one of those two operations. Are they doing anything else?
Could you rephrase the question?
Sure. So, like, I understand. So you say that a reference hash is a hash of, and again, this may be a small detail, but it's like covered here and it's covered in the document, so I think it may be important. The reference hash that I understand is like content storage. So you have like a hash, and you can verify that the thing you got matches the hash. And I understand what a signature does, in that it covers the entire body of the message, and you see the signature and you verify it, right? But I don't understand what the content hash does, except to act as input to one of those two operations.
So the content hash is basically saying that when the server constructed the event, because it may or may not have come from a client in the event format, for instance, it is saying that the server hasn't necessarily modified that, because if you later want to redact the event or remove the unimportant details of, let's say, the room name in a mroom name state event, that would, if you were to remove those details, your signature now becomes invalid because you had to redact to actually do the signature.
But you just said the word signature again. So I'm like trying to understand, can you say that it doesn't use the word reference hash or signature? Was exactly my question.
Okay, the reason that we have content hashes is primarily to delete data so that you can get rid of the human representation that is legible and the content, but you leave the hash behind. And because other things, be they signatures or reference hashes, cover the content hash, you still have the integrity of the history of that room, despite having deleted the human readable data.
I'm entirely lost. Please.
This is Daniel Kahn Gilmore. So let me just make sure that I understand this. The point of the content hash is that you want the content to be covered by the reference hash in the signature without having to retain the content.
Precisely. Thank you. You're better than me.
That lets you audit the transport and other, like the signatures and the reference hashes without needing to be able to see the content.
But then it corresponds to the data you don't have. How does that help you?
Maybe you're looking at logs of how the messages were handled, not at what is actually in it. I don't know. That's my understanding of it. If you could give an example where like you might take action differently based on the content hashes, that might be useful, maybe.
So I guess the idea would be that, yeah, like the content hash basically just ensures that the content itself has not been modified because the signature only covers the redacted or all the unimportant stuff removed. So you, as a server, you technically, without a content hash, would have the ability to change the less important but still human readable or human affecting details of an event.
So let me see if I can restate this my way, which is you have these events, which consist of some set of data. You subset that set of data, and you compute the content hash over that subset. And then signatures cover the subset. Is that so far so good?
I think so.
Okay. And the reference hashes are also computed over the content hashes? Or they compute the entire data value?
Yes, the reference hash covers the content hash.
Okay, so this is like XML DSig, where we have like a bunch of information, but only some of it is authenticated. The unimportant stuff, as you say, is unauthenticated.
All of it is authenticated eventually, but the unimportant stuff, if it fails its own content hash, say on receipt, like it was modified or whatever, then yeah, like you end up just redacting the event down to basically what the reference hash precisely covers.
This is just to stop somebody from spoofing the room history in retrospect and say, hey, there is an event in here which I've synthesized, and honestly, it was here in the linked list. And you can see that, oh wait, no, the hash doesn't match because the reference hash doesn't point to the correct contents there. It's stopping people from being able to modify the transcript in retrospect, which may or may not be desirable. As the final thing says, in a pure MLS world, you don't need these anyway because you can authenticate at the MLS layer.
Next slide, please.
Can I just put something in here? So, I mean, this is probably the most interesting bit of linearized matrix in that it has applicability, I think, in any configuration for MIMI, in that it defines the policy rule system that we were discussing right at the beginning in Richard's neutral tour through the entire sort of landscape of MIMI. The way in which matrix does it is, I think, kind of nice from a UX perspective, in that it goes and assigns a rank effectively to everybody in the room. So you get a number between 0 and 100, which says how senior you are. Then, separately, you define the various thresholds of what people with that rank can do. So they can invite people, or kick them, ban them, they can set policy rules, they can speak, they can invite other people, whatever it happens to be. And so you have this kind of indirection via seniority. For transparency, we stole this directly from IRC and Chansurf style access models where people got a number from 0 to 100, or for that matter from the military, where the number of pips on your lapel or whatever say what permissions you're allowed to do in a given context. Now, the catch is that you don't get full role-based access control on this. You can't have a huge matrix of different responsibilities for different users in the room, but from a pure UX perspective, that's not necessarily a bad thing, and it empirically maps onto all of the DMA gatekeeper style permission models that exist today. The only scenario where we've hit the limit of it has been bridging to Discord, which does have a full role-based access control model where you can go wild doing checkboxes everywhere to give people different permissions to do different things. But this is now, I guess, 8 years old and has been proven in the wild as a approach for doing this. And it also gives you natural tie breaking for, say, different levels of moderation. If you're in, I know, PHP's concerns earlier about having moderators you need to delegate to other ones, you can basically go wild defining additional levels of seniority within the room, so that you always know who owns the room at one end and who's a random guest at the middle, and you can be as flexible as you like in between. Lots of people seem to get scared by this because we call it power levels rather than rank, but I'm hoping it's a really simple idea and it actually matches quite easily onto your normal human social pecking order. Perhaps we should call it pecking order rather than power levels. Any questions about this? I'm sorry for stealing your slide, Travis.
Yeah, I have a question. Can I ask a question?
Hello, Alice.
So there's this notion of like the default power levels, which are, I think, uniform, essentially, right? So for enterprise use cases where like the enterprise already knows that it wants to have users that have different power levels, how does this map onto the existing notion of defaults?
I guess it depends on what type of default you're talking about. If you're talking about the fact that by convention we say that somebody with 100 is an admin, somebody with 50 is moderator, somebody at 0 is a plebeian, or whatever the correct expression is for a general purpose user, then those are like the default thresholds. But within a enterprise context, you can go crazy going and defining additional sort of extensible roles effectively within that order. If you want to have a super moderator or a sub moderator or a sub owner or sub administrator, whatever it is, and you can do that.
Okay, so the defaults are configurable.
Yeah.
Okay. Yeah, Jonathan's also in.
Yeah, Jonathan was first.
Jonathan Rosenberg, 5'9". I want to go back to something I thought I heard you say, which was this works for lots of things, but not Discord.
This is true.
So I want to be clear on what the potential implications of that are. So it means if we selected this and this piece of tech in particular, we could not include Discord in the MIMI interconnectedness without them changing their product?
I would say that we would want to expand this, like probably merge it with the work that Rowan's done to define a RBAC approach, which is almost the other extreme of what we've done here. But on the flip side, Rowan's one has only got the concept of an admin, an owner, and a user, nothing in between. So you're quantized down to one and a visitor and a couple of others. I think it's 6 in the enum in total, but it's still quantized without the concept of seniority. Oh, sorry. Oh, sorry. The microphone was having a moment. So yes, basically Rowan's model, I think, has 6 different roles in the end, and it's quantized to that, but critically there isn't an ordering concept between them. So if you want to have a pecking order of different moderators or whatever, that's out. So jumping ahead, I think the right thing we should do is to breed the two together, have free-form RBAC for Discord, and having a pecking order for the more enterprisey things where VPs are.
So if you're not, so then I hear we're not actually proposing this, then we might just all sit down and wait for the draft. Because otherwise you're going to get a lot of people lining up arguing that the power level linearity doesn't work. But if you're saying you agree, then we should just move on.
Yeah.
Okay.
Richard.
Maybe this is moot given the prior point, but I was going to ask, it seems like the language you use when you talk about power levels here is descriptive nouns like admin and moderator and brigadier general. I was wondering, but the actual things that power levels are integers, so I was wondering, why are integers the right answer here as opposed to enumerated things? As long as it's not, as long as it's quantized somehow.
You don't want to talk about when we've had floats here, which we did briefly. And
I mean, as long as we have 2 non-commuting operators, we can have the proper uncertainty relations. But yeah, no, I was like, are you doing arithmetic with these numbers? Are you summing them?
No,
It's
it's
just some sort of total order.
It's just ordering. And you could do nested sets if you so wanted to express it, as long as you can compare them in size. But the reason you want that rather than text labels is so that, in one environment, you can go and label people brigadier general, general 2 stars, 3 stars, 4 stars, whatever. In another one, you might call them VPs and senior VPs and CVPs or whatever. And the important thing is that under the hood, it maps through to a number. But also, we've really found it to be useful from a UX that it's just a single drop-down slider thing. How powerful is this user in the room? Rather than, oh, let us show you the underlying structure of a massive matrix, which is like 50 rows long and 50 columns wide. I'm frankly surprised that Discord have managed to do that without freaking everyone out. So obviously there is an appetite for full-blown crazy RBAC. At the time, we were worried about recreating NTFS access ACLs, where people just start, creating a Turing-complete hellscape of functionality, and wanted to try to keep it simple. I think we might have oversteered. Long story short, very open to adding in RBAC 2 and breeding it with Rowan's 1, but we're just trying to describe what we have today and get the bits which are useful out of it, at least.
And just in terms of like engineering one out of the other, though, it seems like if you had some language where you had individually enumerated capabilities, like obviously you could build RBAC on top of that by mapping roles down to those, but it seems like you could also build like power levels on top of that by saying, that a given power level maps this enumeration capabilities. Okay. So the atoms here are the capabilities, and it's just a question of how we aggregate them.
Yeah.
Okay.
And how you handle ambiguities if you end up with a full matrix. If you need an ordering of some kind out of that full matrix, then you have to define that mapping, that linearization, as it were.
Okay, sorry. Maybe you just spoke to this, but I just want to get clarity on my other facile question, which is, if you end up in a situation where you have incompatibility between a system that does have the strict ordering and one that does not, like, I understand you're saying that you want to breed these things, but presumably, like, they've not been bred because you have situations where you don't have this strict rank ordering. So, like, what do we do in that case?
Well, it's solved by the folks at Discord who let you do both. So not only do they let you go wild in a clicky matrix thing, you can also then start dragging users up and down in priority and have a weird hybrid of the two.
But on the back end, effectively, you're mapping from something which has an ordering to something which doesn't. Like, ultimately, like, you end up throwing the ordering thing out the window because the thing that doesn't have an ordering has to be supported, right?
I guess it depends on the semantics of how you go and linearize the freeform RBAC thing and how important an actual ordering is. In decentralized matrix, it's kind of useful because we just use it as a way to see who wins in any given punch out. Whereas in an RBAC world, it's going to have to be considered for every parameter, every dimension. But you still get an ordering by looking at the entire vector space of comparisons that you're doing. If that made any sense.
I think I was first. Just a clarifying question. So a higher power level has strictly more permissions than a lower one, right?
Yes.
Okay, so there's no way to create, like, designate an arbitrarily high power level granted exactly one super sensitive permission.
Correct.
Yeah, okay. Thank you. I just
That
wanted
is
to clarify
the big limitation on the whole thing.
Hi, Rowan. I think I see an escape mechanism to either add like sort of arbitrary number levels to an RBAC system, or to add roles to a number system. And I think we can go and take that as some homework. But I think particularly important is for us to figure out what we want people to be able to do both, like, Discord style stuff, and we also want them to be able to work in an environment where they have basically no, the policy is that you have no permissions at all other than to just send messages. And so I think the tricky part is sort of redacting the permissions that you have, that you can even see, that like those things don't exist when you're doing like an iMessage direct group DM, right? So I just say, like, you've given us something to, like, chew on. Maybe if everybody's okay, we go to the next slide and carry.
Yeah, if I can just add on very brief final thing here. One of the nicer things this exploits, which I haven't called out on the slide, is that the permissions are all done by event type. So you automatically get extensibility. So if you want to say, people in this room are only allowed to send this type of message or aren't allowed to send this type of message, assuming that that type is visible outside the envelope on the server, which is a big if. But if it is, then you can go and basically use the event types themselves as the labels, because one of the slight weirdnesses, I think, in your draft currently is that it's special cases, logging and bots and other things is just additional enums, whereas it could be tied through to the actual underlying objects somehow. Probably not due to the envelope exposure problem, but yeah, I can paraphrase, I think. Ron said, yeah, something. Sorry.
Okay.
Next slide. Please.
I'm shorter. So yeah, with the transport, so the current draft is a bit monolithic in what it does. Ideally, it would be broken down a little bit, but the current transport is inspired by Matrix's 2014 era design, and we're actively working on a gRPC replacement just as a technology to sort of experiment with. Currently, it is HTTPS and JSON, again, just to sort of baseline test what we wanted to achieve at the hackathon. Other alternatives include, obviously, anything more RESTful, WebSockets, something streaming based, but it looks like Jonathan has some questions.
Jonathan Rosenberg, I guess, are we gRPC, we have not generally done, I think, here in IETF. I think I actually like HTTPS plus JSON. It can be compressed on the wire and all that good stuff, and it is easy. Let's not turn it into a transport war by picking something better than HTTPS JSON. That's my opinion. Thank you.
Fair enough. There is some precedent in IETF for at least gRPC. I can't remember the exact RFC number, but it is out there. I
Is it a
promise.
standards tracker RFC?
Yes, it's
We went through this like extensively.
it's RFC 9232, I think.
Put it in the chat.
I mean,
I don't think it exists.
I mean, unless there's an RFC which specifies gRPC, then there can't be an RFC which uses gRPC.
We'll look it up later.
It's literally 9232, and it just references out to grpc.io. And the reason is, practically speaking, in terms of running code, there's an awful lot of gRPC flying around.
What's the status? What's 9232? Yeah. So just as a process matter, you cannot have a standard track RFC referring to gRPC.io.
Okay.
So if you want to use gRPC, someone will have to take gRPC and turn it into RFC. Or something. Yeah. So like, I don't actually much opinion on gRPC proper, but like I'm just saying like that's the natural consequence of using gRPC.
Okay.
S expressions.
Basil?
Yeah, I mean, sorry, this is really loud. Basil Onofori from Google. So, I mean, I think I think what we want to kind of look at, instead of just kind of make it a transport war, is kind of make it, what is the thing that makes the most sense from a transport perspective, right? What is the thing that is most optimized? I think JSON and HTTPS are great, but it's not necessarily like the most optimal thing from a scalability point of view. And so we're looking at something that is a little, that can kind of scale as more binary, that is a little bit more strictly typed, that allows us to be able to, be able to interop effectively. Like having come from an RCS world where everything is like SIP based and everything is like loosely typed, those interop projects have been like really expensive. And so kind of looking for something a little bit more prescriptive is hopefully going to be a better thing. Now, if it requires kind of being able to RFC or like a gRPC or something similar, I think that's something that is possible we can kind of explore.
Yeah, there is a 2016 draft. But this might be an opportunity to fix it. And honestly, the feedback that we've had from the big tech companies, not just Google, who we've been working with on linearized matrix, is seriously, if you're going to be putting billions of messages for billions of users, please can we not use HTTP and JSON? Martin.
Yeah, there are other alternatives to JSON if performance is a concern. One of the nice things about HTTP is that you have the ability to negotiate which format you want to use, and it's possible, for instance, that you could use CBOR with some sort of data model that can be expressed in either JSON or CBOR, which is an interesting way to potentially approach this sort of thing. I don't think you have any really fancy requirements for the sorts of things that you're shuffling across these. So it's probably going to be very portable and likely very efficient in that regard.
Agreed. Raphael?
Yeah, just to add to the alternatives, what we've been using in MLS and obviously TLS as well is the TLS codec. And that's now also appearing in some of the drafts, in the delivery service draft. I think Rowan also in some of your drafts. So the advantage of that is that it is strongly typed and it's extremely compact and it's fast to serialize and deserialize as well. So it should meet some of the requirements for gRPC and works well over HTTP general.
We've got 1 minute, 8 seconds left and probably no more time for content wars, but let's talk about MLS briefly. Shall I do this one? So the elephant in the room, which I think somebody referred to at the beginning, Jonathan perhaps, was where does MLS fit into this? In the honestly linearized matrix right now is layering MLS on top for encryption. It also supports double ratchet. Like the Google, one of the Google integrations is using that for pragmatism. Obviously that represents experimental work in supporting MLS out of band from MIMI. Now, at the moment, the membership is being modeled on the server side, and the membership is tracked by the server. Obviously, the user messages are end-to-end encrypted. The linearized matrix auth rules can be applied both client-side as well as server-side, or fully server-side as needed. But for Raphael's and the MIMI DS discussion, I think it's really interesting to try to figure out how you can use MLS itself for the group membership and benefit from the MLS permissions. For expedience and pragmatism in this draft, we're just using plain old non-encrypted matrix effectively for managing the group membership. And the idea is that if a bad actor appears because the server injects them into the room, then you use some device verification to spot that a bad actor is injecting messages in, or there's been asked to be added to the group. And obviously your client shouldn't be encrypting for people that it doesn't expect to encrypt to. I think that might be the last slide. Is it? How are we doing on time?
I think we should discuss MLS. I mean, are there no questions or comments on this?
I mean, this is probably the single biggest question for this MIMI working group session for IETF as a whole. Like, should MLS be layered on top of the transport, or should it be the actual sort of underpinnings for all of the operations of the protocol?
So I don't have a firm opinion on that one. I'm probably not the right person to ask about this, but what I did hear earlier was a very long series of strong arguments in favor of not having MLS be optional. And I just wanted to make sure that was repeated at the mic.
It's in the charter. It's not optional one way or the other.
Yeah,
the question is like, how do we do the layering?
But I think what I heard earlier was that there was maybe I'm mishearing you, Matthew, was that you were suggesting that you designed a transport that could have MLS be optional as part of that. Now, of course, the charter requires that we deliver something with MLS, but that doesn't mean that we deliver something that always does MLS, potentially. I would be very much in favor of only delivering something that only does MLS based on the discussion that I've heard thus far. That may simplify a bunch of things as a result.
So, I mean, it means that the whole thing would be hard-coded to MLS for time and memoriam, and this may well be a good thing. To quote somebody wise who may be standing at the microphone, it's something that one could possibly vacillate on in terms of whether it's a horrible layering violation or whether it's a stroke of genius to have all of the security properties in one place. And in the layering violation perspective, you can almost think of it as, imagine a world where TCP was hard-coded to IPsec rather than IP.
That's fine. I think my point there would be that you do have to plan for the eventual replacement of the thing that you build in this first version. It's not going to be perfect. And at that point, you can do a different thing at that time. But this thing can do MLS always.
So we have 2 minutes, so keep it short.
Yeah, I would like you to imagine a world, Matthew, where HTTP is stapled to TLS, which happens to be the world that we live in. And I think that the fact that we failed to do that in some earlier versions of HTTP, like it took us some ratcheting to get there, like it caused a lot of pain over time. So I think we've discovered that the right answer is to staple the security layer. The other interesting bit of HTTP history is that like the HTTP, if you scroll back in the RFC archives, like HTTP explored both of these paths. There was a version of HTTP, I think it was called SHTTP. I think Ecker's name might be on it. That encrypted, that protected the payload, did the crypto on top of HTTP. And that's not the world we live in either today.
Raphael.
think
Raphael's
Jonathan-
next.
oh, is it?
Oh, no, sorry, Jonathan, and then Raphael.
I'm Jonathan, that's Raphael. We're usually not confused. Jonathan Rosenberg, 5'9". So I'm still deciding whether I think this is genius or crazy. I mean, and I do think it's worth enumerating pros and cons of, we should be realistic that this has pros and cons and like enumerate them. The obviously pro, which is a feature or bug, is it definitely makes it more swappable. I mean, you just, like it or not, like you just did it because the protocols are not strongly coupled together, which is a pro in that it allows for this testing and some flexibility. And the con is whether you state it in a document thou must use MLS, you will make it easier for people to not. There's a definite con I think should think about is that it results in semantic duplication between messages, right? And so that means that what happens if the server rejects the join message at the LM layer, but the commit message gets propagated on? Like this gets weird, whereas the other draft like puts those things together. So I think we need to fully flesh out the pros and cons. I can see why you would do this because it's the easiest way to add MLS to Matrix.
It's not just that, it's also from the DMA perspective that the timelines for folks like Google or anybody else to use this are much, much shorter. We're talking May or March.
That's what feature or bug is not obvious with this thing.
Precisely. There may also be room for both, like when we were discussing. No, so superposition. I think there is both room for MLS Bedrock, MIMI-DS, as Raphael is about to very cogently make a case for, as well as a crappy short-term pragmatic approach that people can like throw up a server in 1,000 lines of code and use it today. And it's a bit weird from a MIMI working group perspective that you would have a sort of short-term pragmatic compromise solution as well as the one true platonic ideal of an entirely cryptographically based messaging protocol like MIMI-DS. I'd love to know within the context of the working group and IETF, and probably not in this session, but Wednesday's one, how the hell you square that circle, Raphael?
Yeah. Let's
Yeah,
stick
so,
on the MLS bit.
Apparently everybody already knows what I'm going to say, so I won't disappoint. I think we should start with security first, because in general, you cannot just bolt on security to an existing system and then assume it's going to be secure. I've gone through the process myself at Wire, where essentially we did not have end-to-end encryption at the time, added it later. It was a super painful process, a lot of compromise, and just not as good as if it had been done the other way around. With MLS, it took us 5 years. We have had a lot of input into that process, so that I think, and I think I'm not the only one, that MLS is a good starting point, and it doesn't preclude to do any of the rest of the functionality on top of it. But we should start with that.
So I don't yet know what I think about the this precise technical question, but I want to echo Martin's point, which is like it's super important to not be possible to remove the encryption. And I'm less worried about what happens if it's like MLS, or ZLS, like whatever it is, we'll call it MLS. That'd be fine. I think to Richard's point, the properties that have made it hard to decouple, like, if you think about like sort of like HTTP and TLS followed by WebRTC followed by Quick. Like what makes us hard to decouple is like the tight integration, conceptual integration between the concepts. I think what I would say here is whether it's like above or below, the important thing is that we should not be designing the decouple, that we should be designing so that we get the maximum amount of security, as Raphael is saying. And if that means coupling, then coupling is the right answer, and the consequence will be hard to disentangle them. So we shouldn't shy away from coupling just because it seems like, we might want to debound it later.
Phil.
Yeah, I don't know.
Philhan Baker.
Oh,
I strongly, please do not couple them directly. I'm currently trying to get WebRTC to do something with post-quantum crypto, and I can't because everything's welded to DTLS, and the only way that I can get things to happen the way that I want there would be I've done a post-quantum key exchange, and I can't use the output of that to get a post-quantum secure WebRTC communication because of the assumptions that are built into the stack. So what I would say is that, yes, say that you have to encrypt the messages end-to-end with a symmetric key, but allow people to put in different ways of establishing that symmetric key. Don't weld it to one particular choice. We know that MLS was based on one set of assumptions. We don't know what the crypto we're going to be using is in 10 years' time, because the post-quantum stuff that we're using today, we have available today, may not be that stuff. And MLS may not be the way to do things. MLS never used threshold. It has a particular set of security goals baked into it, and those goals are not necessarily the ones that you want for every single application of end-to-end secure messaging. And so please don't weld it together. Okay to say that you've got to have end-to-end encryption, but don't insist on one true way of getting the keys.
Very
Conrad
briefly.
was next. Sorry, you.
Conrad. Yeah.
Oh, geez. Just like.
Go ahead with Conrad. Conrad.
Well, I could just go ahead.
Okay. Sorry, can you hear me?
Rowan.
Yes.
Go.
Sorry about this. Yeah. So on the one hand, I want to address this notion of decoupling or coupling. I mean, in the end, both MLS is versioned, and there can be later versions of MLS at some point, and whatever protocol we're building is going to be versioned, hopefully, so we can have agility there, and we can have upgrade paths there. So I don't think any of this is set in stone. And the second thing I wanted to address is this notion of a kind of a temporary solution. I'm a bit dubious, and I guess we would have to see how this works. But if we bake MLS into the linearized matrix draft, I'm wondering if at that point we have succeeded in doing that, we don't already have more or less a DS, and then isn't that the same amount of work as just building the MLS DS in the first place? But yeah,
it's a really good point.
Only tell.
So in the hackathon, we did experiment with going and hooking MLS in on top of linearized matrix, and it did start to look an awful lot like a MIMI DS in terms of it's basically convergent evolution in terms of there are only so many ways in which you can actually drive MLS correctly. The question is more, do you call out to that from the bottom layer, or do you build the entire thing on MLS as the bedrock? Yeah.
Rowan May. So I'm just going to say, if we don't couple MLS to this version of MIMI, then we're going to have a bunch of extra authorization rules about where we're comparing what was in the transport layer to what was in MLS, and we can no longer rely on a lot of the nice features of the agreement inside of MLS scripts. So for that reason alone, I'm pretty keen on doing it MLS only. For this version.
Okay. Thank you. We'll be back on Wednesday.
Thanks.
I don't know. Weird. Yeah. Oh, you made them. Oh. Thank you. No, thank you so much for making it. This is the first time I used donation.